Alright, let's go through that homework just to make sure that we're all seeing how to set up the UI for this particular app. So we're trying to recreate what we see over here. Notice that I do have my app running in the viewer pane, and that can be done by clicking here, clicking on Run in Viewer Pane, and then if you do Run App, it'll show up there instead of in a separate window. So first, up here is our title panel, and so this is just the title. We're going to put that in for our character string up there. And next, let's move to our sidebar panel. So we can see that we have basically four things here, right? We have some text, we have a select input or select eyes input, we have a slider input, and then we have a checkbox input. And so we need those four things separated by commas. But we can notice here that this text appears to be larger than maybe what standard text might show up as, so we need to format that text. And so we can just use a header to do that, and I'm going to use an H3 header, although you could use H2. Not really important that you get that exactly right, just that you know that you can change the size with one of these functions. So we're going to do an H3 third level header for that, and then next up we have our select input box. So for this we can either use select input or select eyes input. Select eyes input works a little bit better with some JavaScript things, so let's go ahead and do that, although it doesn't really matter for what we're doing here. And we can see that this is the name for it. So we need to give it an internal name that we would reference it as in our server file. Let's call it vor lowercase. And then we need to give it the title or the label that they see here. So that's a capital vor. And then after that we need to give it the choices that we might use. And then if we have a pre-selected one like we do here, we need to give it that. So clearly we have pre-selected the value of omni. And we need to give it a choices argument. And in this case, the values of this are the unique values for one of the variables in the MS sleep data set from ggplot2. And so since I know what those are, I can sort of use a function to figure them out, or of course I could just give a character vector with those four values. But I'm going to go ahead and do this programmatically. So I'm going to do, if I did as.factor of the MS sleep data set, vor is the variable I'm looking at. That would convert this variable to a factor, and then I could look at just the unique values by doing levels. And so that's going to return just the unique values of that. It will order them alphabetically by default. Of course, by making it a factor, I could order the levels however I want to show up here. So that's our first input widget. And now we do have a little space here, so we'll go ahead and put a comma and a line break, so BR for line break. And now we're going to do a slider input. So slider input, and let's call this one size internally, and then we're going to give it the label that you see here, size of points on graph. And we need to give this a few values, so we have a smallest value, largest value, pre-selected value, and then what you can change it by. So we'll have to set a few things. We'll do min of 1, max of 10, value is the pre-specified value, and then step determines how far we jump from point to point. And of course, all of those values you would find from the help file, all the different settings that you'd want to use. And so then the last thing we have here is our checkbox input. So checkbox, just a regular old input instead of a group, just with a single checkbox. And actually you can see the different arguments that you would give to this function here, which is another nice thing about RStudio. So we got our internal name, the label, the value that's set by default. So we'll go with, I don't remember what I call this one. Jump to my solutions here. Conservation. And we need to give it the label that the user is going to see. And notice that I do have the label colored here as red. So to get something to be red, we need to actually use some CSS styling here. And so this is kind of a challenge. I'm not going to mark it wrong if you don't get the red here. Although you really could go to the examples that are in the notes where I give you the code that creates the different widgets that you see. From there you can sort of see how to do this. But we'll do H3, give it the color code, conservation status. And then while we're still within that H3, we can then give it a style argument. And we can say style, color, red, I believe is how we want to do that. And the default value is false. And so that should cover the left-hand side of our UI. So that's our sidebar panel. Let me just make sure I got that right. So yeah, style color red. Wonderful. Okay, and now we need to go to our main panel. So what you see over here on the right, and you can see that there are three things. There's our histogram, there's some text, and then there's our data table down here. And so for this, we do need to go into the server just to know what we're calling these things. So the plot should be referenced as sleep plot. The text that we see here is referenced as info, and then we have a render table here, and so that's going to be referenced by just a table. So we go back to our UI. We're going to do, we want to get a plot output for our first thing. And that's not showing up, so that makes me think I'm typing that in incorrectly. Oh, that's right. Well, we want plot output, and now we just want to reference with a string of the name given here. So sleep. We use a comma to separate our items in the main panel as well. So that'll be the first thing. The second one will be our temporary text. So we want text output in this case. We call this info, I believe. Yes. And then lastly, we have our table. And we're not using the DT table in this case, so we're just going to use table output instead of render data table and data table output. And so that's all we need to do, and that should give us what you see over here on the left. All right, so we are ready to now talk about the second file in our Shiny apps, and that's the server file. So what we know so far, we have that UI file, which stands for user interface, and that just controls how the app shows up to the user. We are using a built-in layout, sidebar layout, so we have a sidebar panel and a main panel, and of course we can add a title as well if we want. Later we'll look at how to do even more generic layouts for our UI. There are four types of things that we might put into our user interface: the plain strings, the formatted text, the input widgets, and then the output from the server. We just separate those items with commas within either the sidebar panel or the main panel. All right, so let's talk a little bit more about this server file. So this is often called the back end because this is what's actually running the R code, and you don't ever actually see this code anywhere in your app unless, of course, you try to explicitly output it there. And so we saw a few ways to set up the server file, and so this is one. We just do Shiny server function of input, output, and session. And so we can put any code that we want to run in our app in between those curly braces. And those arguments, input, output, and session, are kind of useful to think about. So input is basically what you're doing in your user UI file. Output is what you're doing here. And then session is a needed argument so that you can do some dynamic UI stuff later on. So we'll talk about that after a while. So remember, the main things that we're going to do in the server file, other than just your usual R code, are use these render functions. And so each one of these render functions is paired with a particular output function. Remember, the output functions go in the UI, the render functions go in the server. And so if I want to output a data table, I might use render data table in my server, use the name that I've stored that object in, as my data table output value. Similarly, of course, if I want a plot, I'm going to use render plot in server. I'm going to use plot output in my UI file. So let's look at some syntax for that and learn a little bit more. So here's some example syntax for creating a plot. So I'm going to use the render plot function, as you see here. And within these parentheses, I just need to run code that's going to return a plot. So it doesn't matter whether it's a histogram from base, whether it's a plot from base, whether it's a ggplot or a lattice plot. Doesn't matter, as long as the last thing that you do is going to return a plot. And so the important thing to notice here is how we are actually specifying our name of this object. So we're doing output $. So we're kind of taking this output object here that we're creating, and we're adding a list element in some sense. Not exactly, but a good way to think about it. And so this is the name that we're creating for this plot. And so this is how we reference this in our UI file. Down below is just another example. I want to have some text that I'm going to return to the UI. So I'm going to use render text. And again, I just need to have some code in here that at the end, R is going to be able to coerce to a string. And I'm going to name that here, in this case, other output. And so in my UI file, as you can see down here at the bottom, I would use text output and then reference that name that we've given it there. And so that's sort of the basics of it. We already know how to create our own plots. We already know how to paste together strings and do things like that. And so now it's just about, can I figure out this syntax of, oh, I have to use output, give the name of the object after a $sign, and then use the appropriate render and output function together. Okay, so let's just talk a little bit more about those names. So remember that every input object we're dealing with has an input ID argument, and that's the first thing that we're giving it as a quoted string when we're defining a UI element, a widget. And so in the server.r, we're referencing that by using input $sign and then giving the name of that. Okay. So we kind of have this input list with different named list elements here. And here's an example. So I'm being more explicit about my arguments to this function in this case. The first one being input ID. I'm calling this one slide. And so if I want to utilize that in my server file, I'm going to use input $sign, that name there. So this is just like referencing a named list input that we've done before. Okay. Now similarly, we saw the output object, we're really doing output $sign the name. And so really we can think about input and output as list-like objects that we're passing back and forth. Okay. So we have output $sign, this is the name we're giving that output object. And when we access our inputs, again, we're doing input $sign slide. So in both of these cases, it's just like adding a named list element. So if you can wrap your head around that kind of idea, you now know how the UI and the server are going to talk back and forth. Right? For the server, when I want to access UI elements, I do input $sign and then grab the appropriate object. When I want to create something that I'm going to be able to use in the UI, over in my server, I'm going to use output $sign, give it a name. Okay. So get a little bit of practice with this and just see if you can make it work. Open up that template app that comes with our studio, add a text output object in the server file using render text, and just have that return the current value of the input slider. And so you want to reference the input just like we saw in that previous example. And then in our UI file, we want to add some output so that we can see the thing that we've created. So add a text output object and see if you can get that to work. So go ahead and take a minute and do that. All right, let's make sure that everybody was able to do that. So I'll show you the syntax for that. So over here in our server file, we want to create a new output object. So we're going to go with output $sign, and then we need to give it a name. So notice that the previous names that we've used so far have come up here, so we don't want to overwrite anything like that. So this is just going to be slider text. And in that, I want to render text. And here I need to reference the input object value and then basically just somehow return that as text. So I'm just going to go ahead and put input $sign. And bins is the only input widget that we have here. And of course that does correspond to our slider input. So I'm just going to do input $bins, and R will be able to coerce that to a string. So no issue there. So our server file is essentially done. We just now need to reference this thing over in the UI. So down here, let's go ahead and add a text output. And we just need to give it the quoted string of that object we created. So let's run this app, see if it works. Great, so now we have the number 30 here. Let me change the bins, changes to 15. So again, getting the hang of how these UI and server parts talk back and forth to one another is really important. When we're over here in the server file, output $sign names our objects. To call them from the UI, we're going to use input $sign. Okay, let's dive a little bit more deeply into things we need to know about to really make this stuff work. So we got to talk about reactivity. And so Reactivity is the idea that whenever the user changes something, your code is going to react, or your app is going to react and rerun certain chunks of code. So reactivity is really important to understand. Our output objects that we're creating, our plots, our rendered text, those kinds of things, they don't actually need to depend on any input. Okay? Those that don't depend on any kind of input will never rerun. So those are going to be what we'd call static code. So it's going to run once, it's never going to change, never going to update. However, any chunk of code in our server file that uses one of those user inputs needs to be reactive. So the code that we're using needs to be able to reevaluate dynamically. And so we're going to need to be in what's called a reactive context to do so. And so any of those render functions that we've talked about are reactive contexts. And so it's perfectly reasonable to put our inputs in there and reference those. The Shiny package knows how to deal with that. But there are some other functions that we're going to talk about here in just a second that will also create reactive contexts that will allow us to do a lot of the other things that we might want to do. So let's just look at an example of reactivity. So here is our render plot function. And so this thing creates what we call a reactive context. And so within here, it's perfectly reasonable to reference things from our UI. And so we can see here, we're going to reference the sample size widget and the other input widget. Okay. So anytime those two things change, this chunk of code here is going to actually reevaluate. And RShiny is really great. So you can actually look at the reactivity in real time. So let's jump into RStudio and let's run this command run example from the Shiny package of 01_hello. Okay, so we're going to do Shiny, reference that package, and say let's use the run example command, and let's do 01_hello. So that comes up down here, over here. Let's go ahead and make this bigger so we can see a bit more. And notice that they have a one file app, so this is just a app.r file, and so that means that they have both their UI and their server in the same file. And so let's see if we can actually see what's going on. Let's do show with app. That's going to make it a little easier. So now whenever I change my number of bins, so I change my input widget, notice that this flashed yellow down here. And so that flashed yellow because it is actually being reevaluated. So this is being reactive to the change of my input widget up here. And the reason being is that because within this render plot function, we reference that input. So here it is right here. Input $bins is referenced. So anytime that that bin is changed, that input is changed, this chunk of code reevaluates. So again, you could have a plot that does not reference any of your inputs, and so that's not going to reevaluate when things change. The only things that are going to reevaluate are the things that are necessary to reevaluate. So anything that depends on a widget that you change is going to then be rerun over here, unless you use some other commands that we'll discuss briefly later, like isolate. Okay, let's talk a little bit more about this reactive context idea. So again, the server can run any R code, but it can't access these input widget values unless it's within what we call this reactive context. And so there are a few ways to create a reactive context. Any of our render functions are creating a reactive context. So again, perfectly reasonable to reference any of your inputs within one of those render functions. So here's an example that does not work. So this is basically doing a one file app. So I have my UI here, where I'm just having a numeric input and a text output. And my numeric input is called NI, and I'm trying to reference that down here in my server. And so I'm doing print input $NI. This is going to throw this error that you see down here. Get reactive environment, current context, operation not allowed without an active reactive context. So this is not being run. This code is trying to be evaluated not in a reactive context. So it's not going to work. So again, anything that depends on an input must be in a reactive context. This render function works perfectly fine. We're referencing an input, but it's within a reactive context because render functions create a reactive context. So how can we do things like print something to the console, or we'll see later how to update some of our UI things dynamically. So how can we use other things other than these render functions? Well, there are two main functions that are going to come in handy here. One is called reactive and one is called observe. Both of these create a reactive context, which means that, again, we can utilize our inputs. What they actually return is much different. So reactive is going to allow you to save an object that you can reference in other parts of your R code, whereas observe is just going to reevaluate when necessary and not return anything. It's just going to reevaluate. So if we look at this new code that we see down here, here's the syntax for using these two. So if I use reactive, this creates a reactive context, and so I'm able to access, say, my numeric input value here. And notice that I'm saving that as value. Okay, so whatever the last, this is just like an R function. Whatever the last thing that you do in here is what gets stored in new var that you see as our object name here. Okay, so again, the last thing that I do within this reactive context, this reactive function, that's what's going to get saved as new var. And what this allows us to do is, again, two things. One, it allows us to use the inputs, so it's reactive, and then this gets saved so that we can use it later on. So if I want to now render some text, I can actually call the result of what we did in this reactive function up here. We just have to access it like a function, which is a little bit awkward. So we're just going to do new var, open close parentheses, and it's going to grab the result of this here. And again, it's grabbing the result of this because this is the last code we ran. So it's going to return a vector with two things in it. Now observe, on the other hand, is going to again create a reactive context, but it's not going to actually save anything for later use or anything like that. So this observe here would just print this to the console and then be done. But it works because we're accessing an input within that reactive context. Okay, so let's just discuss the details of reactive and observe a little bit more. So you might think of reactive as sort of wrapping a normal expression to make it reactive, and then you're still going to save that as an object that you might use later on, like you would with normal R code. And so again, that's sort of the usefulness of this reactive function. I tend to use it for my data manipulation. So oftentimes the user will be able to specify different variables or different conditions on your data set. And then you're going to use the resulting data to maybe create a plot, to create some text output, to create a table output. You don't want to do that data manipulation 3 times. You don't want to do that data manipulation within the plot function, within the text function, and then within the table function. You could instead use a reactive function here, save that as an object, and then just reference it within each one of those render functions. This code is only going to reevaluate if necessary, of course. So anytime one of the inputs change that the reactive depends on, it will reevaluate. And again, the thing I always forget when I'm doing this, you want to access the thing that you saved as though you're calling a function with no arguments. So you want to do that. New var, open close parenthesis here. So here's an example where I'm doing something and then I want to save that and use it in other places more than once. So same exact example, we're returning a vector with 2 things that depends on our inputs. And now I'm going to reference that in my text string, and I'm also going to reference that in my other string. And that just saves me from having to write this code in both of those render functions. Okay, let's do observe now. So observed, again, this just creates a reactive context that's going to reevaluate whenever one of the input values changes, or say you're calling one of your reactive objects, it will reevaluate when those change as well. This isn't going to really yield a result. It's not going to save it anywhere, but whatever code will be rerun. Mostly, observe is used to update your UI elements. So every one of our input widgets comes with an update function that you can use. So here, this is an update of a checkbox group input. And so anytime that no pitch gets changed, that object in my UI gets changed, this code is going to reevaluate and it's going to update my checkbox group. So again, that's usually where this observe is utilized, and we need it here because we are referencing something that involves that input. All right, so we're really getting there now. We have a good idea how to set up our UI, and then now we have hopefully a reasonable idea about how the UI and server talk back and forth, and how to create the things that you want to create there. It's really important to make sure that you keep this page around that gives you the different render and output functions, just to make sure that you can know what kinds of things you can create.